In this introductory presentation to this module, we'll go over the watershed planning process and how watershed coordinators are typically involved. Then, in later presentations of Module 3, we'll explain each of these steps in more detail. In order to effectively communicate watershed issues and goals and be taken seriously by decision makers and local citizens, we need to adhere to scientific principles throughout the watershed planning and management process. So let's revisit the scientific method and how the watershed planning process follows it. It progresses through a series of steps to draw a conclusion. First, we gather information in the pre-planning phase for developing a watershed plan. Then we form a hypothesis, which allows us to develop a sampling plan that helps us understand pollutant levels and possible sources. Then we test with an experiment by conducting water sampling, write down our results through data assessments, analyze those results by calculating pollutant loads and identifying likely sources, and then state our conclusions and make management recommendations for the watershed by completing our reports. As the watershed coordinator, you have to ensure that decisions are founded on unbiased quality data and that this information is properly communicated to your stakeholders. Therefore, reliance upon good quality data is necessary at each step in the planning process. In the pre-planning phase, you're conducting observations about the watershed area to decide where to best focus your planning efforts. So in this step, you're trying to evaluate potential problems, the available data, and potential partners and solutions. The main screening tools you might use in this process include the Kentucky Division of Water's Water Health Portal, which will indicate if the division has enough data to assess the status of the water bodies and, if so, what the status currently is. The Kentucky Division of Water's Watershed Viewer can also be used to see HUC watershed areas, water supply protection areas, karst zones, permitted dischargers, and other data. All of this information is useful in determining potential partners as well as those who might present obstacles in your plans. Wiki Watershed provides a quick review of land use as well as agricultural statistics for the area. This is very helpful in understanding the types of non-point sources in the area. We'll provide you with more guidance on how to use Wiki Watershed later in Module 3. And Watershed Watch in Kentucky's data portal site can also provide you with helpful screening data from citizen volunteers that may have sampled in your area. Some of those volunteers may also be willing to partner and assist you in your efforts. After making preliminary observations and selecting your focus watershed, the next task will be to further characterize this specific area. A wide variety of data sources are mined for information that may impact water quality, as well as results of any past monitoring that they may have conducted. This slide provides several agencies and organizations that may have helpful data for you. We've also developed the Kentucky Watershed Guidebook that lists other potential sources. So after reviewing the data from these sources for its validity and accuracy, it's going to need to be summarized and presented in an easily understood manner. This will become Chapter 2 of a formal watershed plan. Based on the findings of this characterization, a monitoring plan will need to be developed to address any gaps in the data. And an active hypothesis of what might be impacting the watershed or any potential risks of those impacts will drive the sampling project design. Having determined the data gaps, the next step is to develop and implement a plan to collect additional data. Based on existing information, the sampling locations, parameters you'll sample, and the timing of the sampling are selected in order to properly assess potential sources of pollution or water quality impairment. It's important to be mindful that this data must be of sufficient quality to support later decisions. Once the data is collected, it must be analyzed to determine what, if any, pollutants exceed related water quality standards or benchmarks. For those that do exceed benchmarks, the sources and the steps necessary, or best management practices, to reduce the pollution to healthy levels must be determined. The pie charts on this slide show an example of the current phosphorus load allocation on the left and the capacity of the stream on the right, with the division of the loading amongst the sources in the watershed. The stream capacity on the right refers to the amount of phosphorus that can be contributed to the stream while still maintaining water quality protection limits. In both charts, the load, or tons per year, of the whole amount of phosphorus loading is shown. For example, agriculture is currently contributing 261 tons of the overall load, but needs to be reduced to 118 tons through appropriate management techniques. Stream banks are contributing 130 tons per year, while needing to be reduced to 71. BMPs refer to the recommended best management practices for each loading source that will reduce this load contribution, hopefully to achieve healthy water quality conditions. For example, the agricultural loads may be reduced through agriculture and nutrient management BMPs, while bank stabilization and stream restoration might be used to address the stream bank contributions. So a number of each type of BMP and the expected reductions must be calculated for the watershed planning report. It's important that watershed management is adaptive. Once a plan is developed and implementation begins, there must be ongoing evaluation of the success of that implementation and adjustment of the plan. The plan itself should describe how the success will be measured and how the ongoing evaluation and continued planning will be accomplished. It's likely reassuring to know that as a watershed coordinator, you will not be responsible for all aspects of data collection and management. Many of these services will be provided by a paid environmental consultant or other support staff. Fortunately, you'll be part of a team of professionals with different areas of expertise. This chart helps to clarify the technical experts and the watershed coordinator's responsibilities on a watershed planning team. A technical expert will help with actually performing the monitoring, conducting the statistical analysis and modeling and load calculations, generating the maps, charts, and graphs, and helping you evaluate the technical feasibility of implementing BMPs and measuring their success. As a watershed coordinator, your roles will be more involved around coordinating the overall monitoring effort, providing the initial screening and final review of data, and conducting the outreach, education, and communications to the public. You'll also be involved in helping with the implementation of BMPs and documentation that they're achieved. On an effective team, each member should have a general understanding of what decisions and actions the other team members will be contributing. You will also need to be able to articulate your role as well as the roles of others on the team when you're doing your outreach activities. So, although you may not be performing the data analysis yourself, it is important to have some general familiarity with the types of things the technical experts are considering in order to improve your data communication, education, and outreach skills. To be effective, watershed coordinators need to have some background in data collection, management, and quality assurance. This module is intended to train watershed coordinators, not data scientists. In order to help you in your specific role, the following skills and topics will be addressed in this Dealing with Data module. How to assist with the development of a monitoring plan, how to perform screening of data and review of watershed plan documents, how to understand the components of good quality data, and how to explain the related maps, charts, and graphs, and understand some of the limitations of your data. And finally, provide an overview of some simple mapping and database tools for use in exploratory data analysis and communications. This module is not intended to train attendees on how to perform all of these required steps in monitoring. It's rather to familiarize you with these components of watershed planning.